Hello Chem 1A, this is Chapter 3, Lecture Video 10, and we're going to be talking about how to determine the formula of a hydrate just by heating it. We would normally do this experiment in lab if we were on campus. However, due to COVID-19, we're not able to do that. So, if a hydrate is heated, the water molecules that are attached to the ionic compound will evaporate. This is true as long as our heating source is above the boiling point of water. A salt without any water molecules attached to it is known as one of two vocabulary words: an anhydrous salt, an being the Greek prefix for without, hydrous being water, so without water, kind of makes sense. Or you could also call it a dehydrated salt. It's totally up to you which of these vocabs you use, but you should kind of have an idea of what both of them mean, and they mean the same thing. After heating a hydrate, what happens is as the water evaporates, the mass of our sample is going to decrease. If we calculate the difference between the mass of the hydrate before we heated it minus the mass after we heated it, we'll get the mass of how much water was lost over the process, and more specifically, the mass of water within the original hydrated compound. Once we have the mass of water and the mass of the dehydrated salt, we can actually calculate how many water molecules were associated with the salt. For instance, let's say I have an ionic compound that's hydrated with a certain number of water molecules. I want to solve for N here. We use N for a lot of different things in this chapter, so it's very important to kind of distinguish N's. N when we're determining a molecular formula from an empirical formula is different from N when we're determining the number of waters present in a compound. So N is the number of moles of water to 1 mole of ionic compound, or the salt. So what we need to do is we need to know moles of water, and we need to divide that by the moles of the dehydrated salt. Now, if we determine the mass of water using molar mass, we can get moles of water. And if we know how many grams of dehydrated or anhydrous salt there is, we can use the ionic compound's molar mass to get moles of it, and then divide to get N. So let's do an example problem. I have a hydrated sample of barium chloride, 3.256 grams of it. We're going to heat it until the mass no longer changed. By heating it until the mass doesn't change anymore, we're ensuring that we got rid of all the water in the sample. We're also heating it at well above 100 degrees Celsius, and that's important so that the water does in fact evaporate. We know that the mass after we heated it under those conditions is 1.579 grams. We want to know what the formula of the hydrate is. This mass here is not explicitly stated, but it is the mass of the dehydrated or anhydrous salt. And it's equal to 1.597 grams because this is the mass after all the water is gone. We know that the mass of the hydrated salt was 3.256 grams. So if I can subtract these two numbers, I'll get the mass of water that was originally in the hydrated sample. So 3.256 grams minus 1.597 grams gives me my mass of H2O in the hydrated compound. And I get that we have about 1.659 grams of water. Now again, we need N here. That's what we're trying to determine. And N is moles of water over moles of dehydrated salt. So I have grams of water. Now I need to get moles of water. I know the molar mass of water, or I can calculate it. So I can take 1.659 grams of H2O and divide this by the molar mass, 18.02 grams per 1 mole of H2O, to get the moles of water. This will give me 0.092064 moles of H2O. So this value is going to go here. I now need to determine the moles of anhydrous or dehydrated salt? Well, I know the mass of the dehydrated salt is 1.597 grams of barium chloride by itself. So I need to calculate the molar mass of barium chloride, divide by it to get the moles of barium chloride. If you calculate it, the molar mass of barium chloride is 208.23 grams per 1 mole of BaCl2. And if we divide this out, we can get our moles of barium chloride. We get 0.007669 moles of BaCl2. Now, at this point, we can take this number and put it in there to get N. So if we do that calculation out, 0.092064 divided by 0.007669, this will give me an N value of pretty much exactly 12, which it should be an integer value, so we're good there. Now, we actually haven't answered the question. We were asked for specifically the formula of the hydrate, so we're so close. Now we're just trying to write it out, and that will be BaCl2 multiplication dot 12 H2O. And this is my final answer for the formula of the hydrated compound. All right, so if you guys have any questions at all, as always, please feel free to contact me.